Hi class, this is Dr. O'Connor, and this is our second video for Chapter 2, Atoms in the Periodic Table. So in this video, I'm going to talk about the periodic table. You'll notice that I included two files in Module 2. One is a blank periodic table, which I'll talk about in a minute, and the other one is a periodic table like this with the symbols of the elements. Let's get started. The periodic table is made up of these boxes, and there is a box for each of the known elements. So in each box, we have the element symbol. This one here happens to be for carbon. And then above the element symbol is the atomic number. The atomic number gives us the number of protons, if you remember. Remember, Z, the atomic number, that identifies the element. And then this number here is the average atomic mass. You can get periodic tables that show a lot more information in each box, but these are the three main types of information that are important: the atomic number, the symbol, and the average weighted atomic mass. The elements are arranged by increasing atomic number into 7 horizontal rows called periods. So in period 1, we have hydrogen and helium. In period 2, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon, and so on. So the periods are the rows. Now, we also have groups. So the groups are the vertical columns. So for example, this vertical column here is group 1. That includes hydrogen, lithium, sodium, potassium, and so on. Here we have group 2, group 3, 4, 5, 6, all the way through 18. That is one numbering system where the groups are numbered 1 through 18. The other numbering system is the A and B groups, and that's the numbering system I used here. This group here is group 1A, this is 2A. Then we'll go over here, group 3A, 4A, 5A, 6A, 7A, and 8A. Groups 1A through 8A are called the main group elements. In some texts, they refer to them as the representative elements. The B groups we'll talk about in a few minutes. In period 1, there are 2 elements. Periods 2 and 3 contain 8 elements. Periods 4 and 5 each contain 18 elements. And the 6th and the 7th period contain 32 elements. Notice these 2 rows of elements here. The first row called the lanthanides, the second row the actinides. Notice that if we go by atomic number, here number 57 is lanthanum, and then we go here to 58. Okay, so these are the lanthanides. Here we have actinum, atomic number 89, and then here we start with 90 all the way through 103. Okay, so the lanthanides and actinides are pulled out and they're shown below the other elements. Let's talk a little bit about the elements. There are 118 known elements. And notice on our periodic table here, notice this zigzag line, okay? And notice all of the elements in yellow. These are the metals. These elements in blue we call the nonmetals. And then these elements in the lilac color are the metalloids, or sometimes called the semi-metals. Let's talk about those in a little more detail. So the metals, notice the metals do not include hydrogen. Okay, hydrogen is a nonmetal, but it is placed on this side of the periodic table. So everything in yellow are the metals, in blue, including hydrogen, are the nonmetals, and in the lilac color, the metalloids. So let's talk about those in a little more detail now. Some properties of metals. They're solids at room temperature, except for one, and that is mercury. Mercury is a liquid. Metals are lustrous. They're great conductors of heat and electricity. I mean, think about it. We use copper wire, right, to conduct electricity. And they're malleable and ductile. By malleable, we mean that they can be pounded into shapes. By ductile, we mean that they can be drawn into wires, like copper wire. The nonmetals are poor conductors of heat and electricity. 11 of them are gases, including hydrogen. 6 of them are brittle solids, and only one nonmetal is a liquid, and that is bromine. As far as metalloids go, their properties are intermediate between metals and nonmetals. For example, silicon, it has a very shiny, lustrous surface like most metals, but it is very brittle. And just like a nonmetal, it is not a good electrical conductor. Its conductivity lies somewhere between a metal and a nonmetal. So we know that silicon is known as a semiconductor. Now, let's go back to the periodic table, and I'm going to go over some of these main groups here. So let's go here. Group 1A, these are known as the alkali metals, not hydrogen. Remember, hydrogen's a nonmetal, but starting with lithium all the way down to francium. These are the alkali metals. They're shiny, soft. They react violently with water and bases. For example, if I take a piece of pure sodium metal and I add a few drops of water to it, it will burst into flame. Potassium will do the same thing, but it's even more reactive. Actually, as you go down a group, the reactivity of the alkali metals increases. They become more reactive. So potassium is more reactive than sodium. Sodium is more reactive than lithium. Alkali metals are never found in pure form in nature. They're always combined with other elements. So for example, sodium is always found as sodium chloride. Group 2A, these metals are called the alkaline earth metals. Again, they're lustrous, they're silvery. Their reactivity also increases going down a group. So for example, strontium will be more reactive than magnesium. And just like the alkali metals, the alkaline earth metals are always combined with other elements. Then we go over here to group 7A. These are known as the halogens. And they're very colorful. They're corrosive metals. And just like the groups 1A and 2A, they're found in combination with other. So here we have fluorine, chlorine. Both of these are gases. Bromine is a liquid. Iodine is a solid. Group 8A, these are called the noble gases. So helium, neon, argon, krypton, xenon, and so on. The noble gases are colorless. They're gases. And we say they're inert. This means that they are not reactive. So the noble gases do not combine with other elements, although krypton and xenon have been known to combine with a few elements. But for the most part, these noble gases are non-reactive. We say that they're inert. We're going to find, as we go through this course, that the way the elements are arranged on the periodic table, we're able to predict many physical and chemical properties, and this is due to periodicity. So, for example, here we show this graph, atomic radius on the y-axis and atomic number on the x-axis. We have this plot, and what this plot shows us is the periodicity. We see some very sharp peaks and also valleys. So this one here shows us that as we go down a group, the atoms get larger. In other words, the radius increases. As we go across a period, we tend to see a decrease in size or a decrease in atomic radius. So that is one periodic trend. We're going to see other periodic trends as we go through the material. The other graph is for melting point versus atomic number. Again, we see the same trends. There is periodicity here, but notice that our peaks and valleys are not as sharp, and there are a lot of exceptions here. Okay, same up here. When we're looking at atomic radius, we'll find as we get to this part of the periodic table where these elements are, we'll see that there are exceptions to these trends, but we'll talk about that much later. Back to the periodic table. So we know where the alkaline metals, the alkaline earth metals, the halogens, the noble gases, the metals, nonmetals, and metalloids are located. We also know about the lanthanides and the actinides. Let's take a look at groups 3B through 8B. And so this whole block here, let me try to draw a straight line here. It's really difficult with the pen to do that. Oh boy, not very good. But this group here, this whole block here, these are called the transition elements. These two rows, the lanthanides and the actinides, are called the inner transition elements. So inner transition elements. On Blackboard, I posted a blank periodic table, and I would expect you to be able to label a blank periodic table. Let me show you what I mean here. Let's go ahead and label the metalloids here. So we have boron, silicon, germanium, arsenic, antimony, and tellurium. So the blue corresponds to the metalloids. Let's go ahead and do the nonmetals. We'll do those in green. So nonmetals. And we have carbon, nitrogen, oxygen, and fluorine. Of course, all our noble gases here. So these are all our nonmetals. And then everything else are the metals. Now, while I'm doing this, you guys see something that I missed? Hopefully you see that I missed hydrogen, because hydrogen is not a metal. It is a nonmetal. So let me go ahead and color that. So we have our metals, metalloids, and nonmetals all labeled here. Let's go to group 1A. First, I'm going to label the periods 1, 2, 3, 4, 5, 6, 7, and our groups. Here we have 1A, 2A, 3A, 4, 5, 6, 7, and 8. And we know that group 1A, these are the alkali metals. These are the alkaline earth metals, group 2A. And then 7A are halogens, 8A are noble gases. Okay, we have those labeled. Here, this row here, these are our lanthanides. And we have our actinides. And together, these two rows are our inner transition elements. And these elements here, try to get a halfway straight line going down here. It's really difficult to control that with the pen. So we know that these are our transition elements. Okay, let's see. Now, there is something that I want you to do, and that'll be explained in the next video. But I want you to label groups 1 and 2A. Let me find a different color here. So groups 1A and 2A, and we're going to include helium. This is helium. So groups 1A and 2A, including helium, we will call the S block. All of the elements in groups 3A through 8A, with the exception of helium, will be called the P block. Our transition elements here, those will be the D block elements, and our inner transition elements, these two rows here, will be called the F block. So do practice labeling a periodic table like this. I want you to know where these main group elements, the alkaline earth metals, halogens, noble gases. I want you to know the metals, nonmetals, the metalloids, the lanthanides, actinides, and the S, P, D, F blocks. All right, so make sure that you can label a periodic table like this. You might be asked to label one or partially label one for the exam. This concludes our second video. In the next video, we're going to talk about electron configurations.